today's at-home lab, I'm going to show you how to do a fun demo with milk while also exploring properties of water, especially that of surface tension. Now, surface tension is a very cool property of water. It's one of many properties of water that really is essential to a lot of how life functions and is able to survive here on Earth. But surface tension itself is a property of water that allows water to resist external forces because of cohesion. So these water molecules here are all attracted to each other, and they have a tendency to form small, tiny little bonds with each other. But when there's no water on the top to form bonds with, the bonds on the sides and underneath will be even stronger. You might be able to see surface tension in action when you have a cup of water that's totally full and there's sort of a bubble on top, or when you try to get a paper clip to float on the top of this water. Now, this paper clip itself would probably sink to the bottom if I just dropped it right in, but very carefully, because of surface tension properties, the water molecules can support the paper clip, even though the paper clip is more dense than the water itself. So in today's experiment, we're going to be using a few materials that you can find at home. First, you're going to need some dish soap, which I've put a little bit in here. You might need some either toothpicks, or I have just a Q-tip here, that'll work as well. And you're gonna need some milk. I'm gonna use whole milk, and if you can get a fatty milk like that, that'll be great. And you're also gonna need some food coloring, as well as some small dishes. I'm gonna use Petri dishes today, but feel free to do this with Tupperware or any small, shallow bowl that you have. Now, before we get started with our demo, dish soap itself, it actually is a surfactant, which means it's gonna be able to disrupt surface tension. So by just touching the water with a little bit of my dish soap here, you see I was able to disrupt the surface tension there, and the paper clip sunk down. To see how this surfactant actually disrupts the molecules on the top of our liquid here today, what we're gonna do is help visualize it with food coloring. So what you're gonna do is take a couple of different colors and put them close to the center of your Petri dish. Let's take some red here. You can feel free to put a few drops in there. Put some green. Oh, that one went straight to the bottom. And then a little yellow. Oops. All right, so now I'm gonna put some dish soap on the bottom of my Q-tip, and here we go. Whoa, very nice. So you see with the introduction of that dish soap, I really disrupted those molecules at the top, and they spread apart, moving towards the exterior sides of our milk. Now, what do you think would happen if we added more? Let's go ahead and try another one. For comparison, let's just put our Q-tip into the center here without any dish soap. Not a lot happens. I mixed up my food coloring a little bit though, because there was some green that sunk to the bottom. So now let's add our dish soap once again and see what happens. Whoa! So feel free to try different variations of this at home, make your own milk art if you want, but have fun exploring the properties of surface tension with milk, water, and a little bit of a mess. See you later. And soap, let's try, oopsies. Woo. I made a mess, but I got it out, guys.